Okay, we've got a compact water heater from a Bosch Neff dishwasher. This thing's used in all sorts of dishwashers. I don't know how many models there are. I've lost count, but it's a lot. Okay. Now, anybody that's owned one of these will have, after 3 or 4 years, would have to have one of these fitted. And it's basically the pumps in there, and inside this housing here is a heating element with a metal shroud around it. This is the thermostat, which is a negative temperature coefficient thermistor. This is the pressure switch on the end. There's a diaphragm inside that switches this switch, and this switch is basically just in series with the heating element, and there's the contacts to the heating element at the end. You'll all be familiar with this, your engineers guys that have had these things. Anyway, these heating elements, either they go open circuit, or if you've got an RCD in the house, a residual current breaker, the dishwasher will trick the breaker out at some point through the cycle. When it turns this heater on, it'll detect the RCD in your consumer unit on the main supply will detect the fact that there's an imbalance in current flowing between live and neutral, i.e. some is going to ground because it's leaking to the ground connection or the case on this heating element in here. This is the heating element, so it looks like these are the spares, okay? They're the SUS 301 spares, which I'm going to show you how to plug that in. Alright, so that's the spare heating element. So, yeah, so that's what normally happens to these, and either, if you haven't got an RCD, it usually leaks and leaks and leaks, and suddenly it will go shorting to ground, and then it will blow the fuse completely, and you'll find your dishwasher will turn on, do a bit, and then when this heater cuts in, bang, the fuse blows, usually in the plug actually. So very common failure, breakdown, leakage, or blown open circuit heating element. These are much more reliable. There's a separate video I've done on how to test the thermistor. And then some have this flow sensor here, which is just a photoelectric flow sensor to check that water is flowing in the unit. Most of them don't have it. I don't know what it's for, why some have it, some don't, but others just got this, the moulding tool has got a blanking plug in there, so there's nothing protruding into the water jacket. It's just sealed off from the outside world, but the detail is still there, but nothing mounted on it, okay? And then you've got your outputs here, and then some have got this motor on the bottom, which has got a motor which goes one way or the other with a switch, and switches in. You can just see the edges of that diaphragm there, with a diaphragm valve or flap valve or rotary valve, and it just changes the flow rate and the pressure to the upper and lower impellers in the dishwasher, okay? So if yours is only washing on the bottom one or on the top one, and your top rack seems to be not very clean, then whip this motor off and put some power on the motor contacts and make sure that the thing is rotating freely and the gears aren't stripped. I haven't actually seen any problems with these. I have seen one where the input filter to the water system had been left off or dislodged, and I'd seen one with something wedged in there, which meant that the top rack wasn't getting any liquid, and the bottom rack wasn't getting much either, because you can see in that position it's almost shut off completely. Right, so reliable unless something gets stuck in there, but if you've got one rack only, you know, it's not washing very well, it could be just the controller, this rotating valve, vane valve, which changes the flow from upper to lower basket. So that's basically it, and this assembly I think is about £100 or 130 euros in its various forms. This is the most expensive form, which has got this motor, it's got the flow valve, and as well as the normal components, which are the thermistor and the heating element. So anyway, so if you're watching this, your heating element's gone. You can test it with a normal meter. If you just get a meter, put it on high resistance, I put it on my 200 meg range, and then check between one of the connections on here, which is the ground connection. See these yellow wires? This is from a scrap dishwasher, by the way. And then connect onto here. You can see the meter is detecting 60 megohms. So that's leaking to ground. This is why this has been blowing the trip. Right, so this has blown the trip out in the RCD. So this heating element is gone. If you measure across the heating element, which is the normal resistive heating path where the current should flow, it's a 220 volt unit, it'll be around about 20 to 25 ohms, okay? That gives you your 10 amps or 2.1 kilowatts. So it's okay, this would work, but the power is the live electricity is leaking to the ground connection, which is tripping out the safety trip in the house. All right, very common fault. 100 quid, but you need to get hold of one of these heating elements. I've got some if you need them, and once you put that in there it'll be fine. Okay, so this is a low cost alternative to buying the whole bloody lot and putting the whole lot in landfill. Alright, so I'm just going to show you how to get this out. Okay, so this heating element is mounted into this plastic boss at the end, and it's held in position by these clips, basically spring-loaded clips, which get compressed under these parts here, underneath this keeper, and then spring up. And then to prevent them springing up, they've got these little webs underneath which hold them in position so that they cannot disengage from the catch. Okay, so if I just zoom in on that and give you a quick look at it. So there's these tanks, look. You've got the plastic tank coming through. It's got a barb on the end with a shoulder there which locks in behind this plastic circumference there. This part here locks that, so it pushes through, pushes this in engagement, it comes through, pushes this out of the way. This is a locking tang, and then it pings into position, then that pings back underneath. You can see this is in there to stop that being pushed in that direction to disengage this. Okay, so if I just quickly zoom back out again, I think I can do that. Yes, I can, and I'll show you how you get these out. I've seen them very chewed up. Some people have obviously taken their full manly strength or lady strength into operation, and I used I've got a couple of old stainless number 10 scalpel handles, and you can see the ends are kind of tapered and just about the right shape for doing this. And if you, I know from experience, if you've got the right sized implement to shove into there, into this space here, to push to disengage this barb, it makes life a lot easier. Alright, and I've seen them, other people have had them apart before, and I've gone to fix the dishwasher and it was all chewed up and horrible, and it was due to them not having the right size tool. Alright, so let's zoom in a little bit. This is going to be a bit awkward because you do need to provide or use a lot of strength on this, and well, I do anyway, you might not need to, and it is a bit tricky, and I can't get over the top of it because otherwise you won't be able to see, so you have to bear with me. Alright, so pulling this, pushing this out, back out the way, put my thumb in there to prevent it re-engaging. Right, so I've got the clip pulled back. Then if I just shove this in here like that, you can see it will disengage the clip. Alright, so I'm going to leave that one in, so that one's left in. Now I'm going to do the same to the one on the top, this one. Pull that back. Try and get that in there at arm's length. There you go. So that ping you heard wasn't anything breaking, it was just this supporting web popping out of the way. Alright, so you have to kind of put some pressure on it and then push it. So they're both in, and the name of the game is just to push it out slightly so that you get the edge of the barb underneath the retaining edge and on two of them. Once two of them get locked, you see, now just push that a little bit further in there. Now these two are disengaged, this one and this one is disengaged. You can see that's pushed out the way, that's sitting underneath the edge, and this one's the same. Alright, so you can see they're disengaged now. So now if we just disengage the other two by doing the same thing without allowing it to pop back in. Now that's the third one disengaged. And then finally number four might be a bit more tricky. Push that out of the way, and shove that in there, and she's coming. Right, there we go. So that is how you do that. It's easy if you've got the right bit. Right, so pull, and the big reveal is coming. Check we're still recording, we are. Roll of trumpets, or drums, fanfare, and she's coming out. Might have to leave her a little bit on against using application. It's just like how I normally do it, except with quite a bit less squaring than usual. There we go. So now you can see the metal shroud that goes over the heats. You can see the metal shroud which goes over the heating element, and that hole there aligns with the bottom of the NTC thermostat, right? So pull that out, that's just a hole in there. Take the shroud off, remember to put it back, and remember to put it up the right way. And this is the heating element. This is the part that's going to be replaced by this part. Stainless heating element, okay? So we're going to swap that over, this into there. And to do that, I find the easiest way, because you have these electrical connections on the end of the heating element casing. There's these push-on washers which have got barbs on them, which basically they only go really in one way. And I've tried bleed ring them off before, but it's not much fun. It's much easier to cut the element off and carry on pushing it in the right direction, and you can just put them over the top of the new ones and push them on to the same depth as they are here. So noting the actual distance between the end of this element and there, or the mount protruding out this side, clearly this can be moving back, and if this element is moved too far back, these will be too far that way, and this will be too far close to the rubber, and the whole thing won't go back together. So when you put it back together, I'll show you how to do it. Do take a note of how far the end of the element is above this edge, because you need to put it back in the same position. So what we're going to do, in this one here also has got the earth connections on it, you can see it here. So that's the similar type one-way push-on locking bar. We used to call them spire clips, I think. Anyway, we need to get those off and get this element out. So what I do is I just cut through here, take it to the bench, hacksaw through that part, remove any burrs from it, so we don't want to damage the rubber seal when we withdraw it, and cut this one off as well, right? So I'm going to go and chop those off, and then when I come back we'll stick the new element in. So there's part cut through. It doesn't take much cutting actually. There's only a bit of ceramic. It's only ordinary ceramic. It's not asbestos or anything, so it's not hazardous. See, that's the end of the heating element I've cut off, and there's the two stubs left of the heating element. I put a file round so there's no. Actually, there is a slight burr there. If I can find my file, I shall remove it. One moment. Yeah, you don't want any burrs on this to catch the rubber as it goes through. You really don't. That's better. So we're pretty much. Let's get a new set of files, I think, for the shed. Okay, so she's chopped off, right? So now you can just get hold of these things and just push them out. Noting that the one with the earth goes this micro switch to the top. Looking from the back, the earth one goes on the left with the tags sort of up the top. Pull it through, and then pull the other one, push the other one out. He says. That's quite a tight one actually. Might disengage the rubber seal first from the. Yeah, if you push it that way as well, it'll disengage the seal from the pinch hole. So now you can pull the whole seal will come off. And you can see this part here gets compressed into that section there to seal on the bar. You'll find some sort of tacky, horrible grease on the back. I'm not sure what the purpose of that. I don't think it's anything that's leaked in there, because they all have that kind of oiliness in there, just to lubricate this pressure switch. So anyway, let's pull it out now. Come on, baby. Save my fingers. Okay. So that's the element now removed, and then what we'll have to do is put the new one back in. So back in a moment. I'm going to wash my hands. Yeah, I forgot to mention on these stubbies, these are the bits I just removed. What I do is I cut them as close as I can to that washer with a hacksaw again. So I make another cut with the hacksaw. It only takes a minute. And then literally these only have to move. You can get hold of these pliers and just wiggle them over the edge. It just saves bending and wearing these out, because you want them to retain a degree of spring so that they're effective when you put them back. Okay, so I'm just going to do that. Right, so after a second cut, what we're left with is with this little stubby ends and just the washers on them. And you, by hand, they're extremely tight to get off. Okay, that is quite forcefully pushed onto there and not easily dislodged. And if you get pliers and start hawking them around, you'll bend them. All right, so yeah, that's on there. So let's just try socket underneath, support, socket on top. So we've got this arrangement here pushing through. I would normally do this in the vise and just tighten the vise up, but in the interest of doing stuff online, just to show you this instruction, get the universal tool out and give it a bash. Locate it carefully underneath, give it a bit of a tap. There you go, that's that one done. Flatten. And then the other one. Take this connector off. Come on. There we are. So there's your two washers, which we're going to tap over to cover over the new element when it's in position. Alright, so let's put those to one side. That part of the work is complete. So now this is just the grease they use. I'm going to put a bit of fresh silicone grease on that. One moment. Don't really like the look of that stuff. Just get some grease. Alright, okay, so this seal goes over the here, over the top. I'll just zoom out a little bit for you. It's symmetric, so up and down wise it doesn't really make any difference which way it goes on. Push that over the rubbers. Come on baby, you can take it. There we are. Right, goes in there. So we put a smidging of silicone grease on it. I'm going to have to use the end of my scalpel. But on the shafts and on the seals, just to make it slide in nicely. I'm going to get it to about the right depth in here. About there. You've got quick measurement there, boys. You've got about 12 millimeters to the top of the insulator there, or 30 millimeters to the end. 30 millimeters to the end of the spade. So 30 millimeters between this point, if I just measure there, and the shoulder which it comes through. Okay. Whilst holding that position, you push this rubber seal into position around the root of the. Has to make sure it's in that cavity that the seal ring that's on here is pushed in and pushed into this plastic moulding, and as it does, it grips onto the heating element itself and then makes a seal. Okay. Yeah, so to put this on, you rest it vertically on the desk with the end of the element pushing down onto the desk so that you don't dislodge it in the plastic housing, and just generally tap this gently down until it touches the plastic white moulding. Like that. Ah, she's all back together, the clips are all engaged properly, or are they? That one isn't, is it? It is now. Just make sure that these supporting webs that prevent the clip from disengaging are actually in position underneath the barbs, alright? Underneath the clips. That one is. This one isn't, so it needs to go in a little bit further. Just push it in deeper and just push it, there we are. So that one's now engaged. And then that one's engaged. Right, so that's fully home, it's all put back together, ready to be powered up and tested. So that's how you change that heating element.